Okay, good morning, everyone. My name's Janet Dunnett, and I'm delighted to welcome you to our autumn learning programme. This series offers a series of knowledge-sharing sessions on topics you've told us that are of interest. Today's event is net zero homes, or should we say low carbon homes? Let's find out. Next slide, please. This autumn learning programme is brought to you by Homes England Local Government Capacity Centre, and this slide summarises who the Local Government Capacity Centre are. Next slide. The learning programme is just one of the tools offered by the Local Government Capacity Centre. Our offers also include the Housing Information Hub and a capacity analysis tool, which you can also use to assess capacity. We look forward to hearing how we did in the survey poll at the end of the session. Next slide, please. On the screen, you will see a breakdown of the session today. So we have myself, obviously speaking, and then we have Ben Richardson Bureau-Happold, who will give an overview of net zero carbon and what that means, and also operational carbon. And then we will move on to embodied carbon with Dr. Mansi Desai from Pearl Frischman. And we'll also look at some case studies while Mansi is speaking, move to the Q&A, and then some final remarks, and close hopefully by 12. We'll be finishing with the Q&A, as you can see, and then we'll be drawing the session to a close, and we'll have some further polls, and we'll get some immediate feedback on the session and your ideas for future sessions. So I'm now going to hand you over to the first presenter, Ben Richardson. So if we could move to the slides for Ben, please. And Ben, if you could introduce yourself.
Good morning, everyone. Thank you, Janet. Yeah, my name's Ben. I'm Director of Sustainability and Physics at Bureau-Happold. I've been in the industry for about 20 years. Got background in physics side of things and worked in the residential sector. And yeah, we've worked with Homes England for a little bit recently, looking at their whole life carbon targets. And yeah, I'd like to share a little bit about net zero carbon and operational energy. So if we could move on, please. And on to the next slide. I suppose the key question is, what is net zero carbon? And for most of my career, this question has been asked. But finally, I feel like the industry has come up and agreed on a definition and documented it in this net zero carbon building standard. Now, this only just came out last month. It's in pilot version. It's not due to be fully operational for a little while. And here are some of the headlines. It targets both embodied and operational carbon, and we'll talk a little bit about both of those as we go through today. There's a phased approach to targets, and what we mean by that is that over time those targets will get more and more onerous, particularly as the electrical grid decarbonises and as we shift towards a more carbon efficient world. Like I said, we've all the industry have agreed on it, which is half of the battle. There's been something like it's been 2 years in the making, and about 350 people that have been involved in this definition. So we hope and foresee that it will have a little bit of momentum moving forwards. It's got some useful renewable energy guidance in there, and limits around renewable energy generation. And there's also some useful content around how you might, or developers might go about procuring energy, or how occupants might go about procuring their energy. And should people wish to have the badge with offsets, there's some guidance around carbon offsets in there. And like I say, it's not fully effective until next autumn. So we've got a year where we're going through this pilot phase. But I would encourage you to have a look at it and refer to it in either your legislation or perhaps when you're holding developers to account. It is punchy, shall I say? It's targeted at the higher end and the more progressive developments. And there is advice around retrofit in there as well. And at the end, I've done a bit of a fundamental guide to this standard, which condenses the 100 pages into 3 contents pages and gives you a very, very high level summary of what's within the guidance. So we'll share that round afterwards. Next slide, please. So when we talk about net zero carbon, we're referring to the whole life carbon of the building, and that includes both the operational and embodied elements, as I mentioned. This guidance on the left, the RICS whole life carbon guidance, is a commonly referred to document. There's a little link at the bottom there, but essentially it maps out the carbon life of a building. And if you look at the diagram on the right, you start at the sort of 12 o'clock position, where you extract your raw materials, you transport them to the factory, and then down at the I guess 4 o'clock position, you've got where you construct the building. So that's your upfront carbon. That's where you start. And Mansi will talk a little bit more about the embodied carbon associated with that. And you then go through these, what they call modules, A, B, C modules. So A is that upfront, B is in use, and then C at the top is when the building is either reused, had change of use, or demolished. So that's the full carbon cycle that we refer to. Next slide, please. I think one of the problems in this world is the terminology. Sadly, it's full of jargon. And even the professionals like myself and Mansi get caught up in it sometimes. But this is, I think, a handy little guide. This incorporates some of those ABC modules that you saw on the previous slide, but kind of defines the terminology a little bit. And you'll loosely hear people refer to upfront carbon, embodied carbon, life cycle assessment, whole life carbon. And sometimes they're used interchangeably and refer to the same thing, but this is a handy little diagram that spells out exactly what terminology is referred to what modules, and this again is found within that RICS guidance that we spoke about. So hopefully a useful aid memoir to get you up to speed with the lingo. Next slide, please. So moving on to operational carbon and the following slide. One of the questions that I'm going to attempt to answer over the next 20 minutes or so is, how can designers balance the operational carbon with embodied carbon, along with all the other design factors that you need to consider when designing housing? So the following 10 slides are my top 10 examples of where you can get the biggest bang for your buck, the most positive outcomes from one design solution. And I would encourage you all, perhaps if you're in local authorities, to hold developers account to maybe make sure some of these top 10 design interventions are in designs, and ask developers why they're not. And if you're a developer, then maybe you can challenge your architects around some of these design interventions. I've tried to put a cost-effective stamp on some of these slides where I think, I'm no cost consultant, but I think there's a relatively biggest bang for your buck in terms of the design solution and how much it might cost. Doesn't mean it will cost nothing, but it means relatively little in comparison to the outcome that it achieves. Excuse me. And then the icons that I'll show on the right as we go through are what the design feature will impact on. So sometimes you can have a positive impact on all four: embodied carbon, operational, daylight, and thermal comfort. Sometimes just a couple. So I've tried to highlight where they make the biggest difference. But what I should say, I think one of the key things I've learned of late is that good quality homes is the single best thing to aim for. If you can design, build, and have good quality homes in your local authority, they will be loved, they will last for longer, and therefore they have a much greater sustainable outcome. So that kind of takes precedent. I think that's the easy nugget to take away. So next slide, please. Let's dive into the top 10. So in not necessarily any particular order, number one is airtightness, but with mechanical ventilation with heat recovery. And forgive the image, but if you can encourage developers to make the homes airtight, but introduce MVHR, the two need to work hand in hand. And I think they're relatively cost effective. An MVHR unit and its constituent parts will be £3,000 to £4,000 per home. So relatively low cost, but huge output in terms of operational carbon, it makes a big difference to seal up the homes and reduce your operational energy and carbon. And it does have an impact on thermal comfort as well, because you get less draftiness through the homes, and probably a fifth impact is well-being. You get much more health conscious homes, if you like, if it's designed well. Next slide, please. So this is a particular bugbear of mine, and something that's really easy to get right, and something that is cheaper and will impact all four. This probably should be top of the pops. This one is not have floor to ceiling windows. It's a really simple design intervention, putting an upstand into the glazing. Glass has a high embodied carbon content, and wall does not. So less glass, more wall equals good. Operationally, on the whole, it has a benefit, because glass it leaks heat a little bit more than walls do, and homes do tend to they're in heat demand for most of the year. There is a slight nuance to this, where on the south facing facades it is sometimes beneficial to have more glass, and you make the most of the winter heat gain. But on the whole, upstands and not having floor to ceiling windows is a good thing. Daylight wise, you don't get huge amounts of impact having glass below, say, 800 millimeters. Daylight is not compromised. And from a thermal comfort perspective, you get a lot of cold downdrafts off of big glazed panels, particularly in the winter. So they cause a little thermal comfort asymmetry, and they're not so effective. So hold your architects and developers to account. Don't have full height glazing. Next slide, please. So insulation specification is another relatively cost-effective impact you can have. If you move towards raw materials, in particular, sheep's wool and the like, can have relatively significant embodied carbon impacts in terms of good impacts. And for sure, if it's specified right, you can have very big operational carbon impacts. The thickness of the insulation also can make a huge difference to operational carbon. Obviously, it doesn't impact daylight so much, but thermal comfort will have a slight benefit for trying to minimize any condensation issues, any cold downdrafts. But top two tend to be the most impacted ones there. Next slide, please. So thermal bridging is a tricky one. It's a detail. Devil's in the detail. It's certainly cost effective. It needs to be done right. It's a REBA stage 4 kind of level of detail that designers need to be considering. And I suppose, to summarize, it's trying to make that yellow bit in the wall, the insulation in the wall, consistent all the way around the building. And if you imagine it like a big coat wrapping you up in the winter, to keep that consistent layer, and not having any breakages in that layer, like, say, balconies penetrating through it, and even where you have junctions between your wall and the floor, trying to keep that insulation layer consistent. It's not so impactful on embodied carbon, and certainly not impactful on daylight, but it will have a huge operational carbon benefit. And again, it will have a thermal comfort benefit, given that you won't have any condensation issues. You'll have less amounts of thermal downdrafts and lower thermal asymmetries across the home. So definitely one to question your developers and architects on. Next slide, please. So where glazing is located and how big that glazing is, this talks to design number 2, that glazing floor to ceiling one, but it's very similar. This is a very cost-effective one. It's something that architects can look at in the early design stages, sort of looking at the window to wall ratios here. And if you have good architects, good consultants, they can do a bit of a parametric type analysis early on to work out where you put your glazing and how big it needs to be. And there are some nice passive house principles here, where, you know, simply put, if you can encourage more glazing to the south facade, you get more of that beneficial winter solar gain. You obviously need to protect in the summer when it gets a bit too hot with shading. But the principles of more to the south and less to the north are good principles to follow. Not always practical, I appreciate, on a site when there's maybe other considerations to take into account, but generally speaking, if done right, you can have embodied carbon benefits, operational carbon benefits. It can maximize your daylight and optimize your thermal comfort as well. So good design solution there. Next slide, please. So net zero carbon definitely is moving away from gas and more towards electric sources of heat. So going fossil fuel free is a big tick in the box. I'm not sure it's cost effective, so the stamp doesn't apply here, but big wins. Maybe one day it will become cost effective, but big wins in terms of embodied carbon and operational carbon for sure. And strictly not a net zero carbon building if you're still on gas or using fossil fuel in any way, shape or form. So a move towards electric heat and electric houses is definitely a good place to go. Next slide, please. Number 7, so external shutters. This, I'm sure many of you have been on the continent, around your travels around Europe, you'll probably see these are prevalent on the continent. And as the UK is moving into a more warmer climate as a result of climate change, we are seeing warmer summers, and shutters externally are a really beneficial design feature generally, and they offer a lot of quality to a home. They do compromise a little bit on embodied carbon, but if they're done with natural materials like timber, especially for the sort of lower rise housing, it's minimal impact on embodied carbon, and it ticks the quality box that I spoke about earlier. And what they do is they give you operational carbon benefits, because it means you can have the right amount of glazing in the right places to get the most from the winter sun, but then close those shutters to protect you from the summer sun. They do help with daylight, because again, you can not worry too much about overheating, and then optimize the glazed ratio for daylight and make your windows a little bit bigger for that. And then thermal comfort you have a benefit from, because you can get some thermal benefits from those shutters as well, and protect from winds as well, potentially in the winter time. So really, really good design feature, and we're seeing a few more of these being introduced in schemes at the moment. Few concerns on high-rise buildings around wind loading and fire and the like, but certainly for lower-rise buildings, it's a big tick in the box, and something we should take learnings from our European neighbours and global neighbours for that matter as well. Next slide, please. So there is and should be a big move towards centralized energy and district heat networks. And what this essentially means is taking away the house by house approach to heat and moving it into one energy center. That energy center would supply the heat in a relatively low carbon way or zero carbon way, and distribute it through heat networks to homes. There's embodied carbon benefits here, because having one plant is better than having loads of little plant across multiple houses. I think it can and should be cost effective for that same reason. You've got one bit of kit instead of multiple bits of kit. But I guess you've got the infrastructure to deal with as well. Operationally, there should be some carbon savings as well, mainly because you get efficiencies of scale. Having bigger heat sources in your energy center will give you economies of scale and efficiency savings. But also, if you're in an area where you might have different end uses like an office, or maybe even we're seeing a lot more data centers in cities and urban areas that are giving out heat, and if they can share that heat with homes, then you get huge savings there too. So networking that heat through these energy centers is a real benefit. Obviously, there's not any benefits to daylight and any benefits to thermal comfort, but certainly from a carbon perspective, it's a big tick in the box. And the likes of Greater London Authority are pushing London authorities towards district heat networks, and there's many other authorities that are pushing in this direction too. Next slide, please. So form and massing is definitely very much an early design stage thing. It's something that architects and their consultants like myself would help with. It can be really cost effective if done right, and there are some passive house type tools that can help with this. This is about orientation, it's about the proportions of your building, where you position it relative to the sun that each building is exposed to. It can have benefits to embodied carbon and operational carbon, and you can get the most out of the daylight and exposure, as well as maximize thermal comfort. Multi-factor thing to consider here, and can often be a little bit impractical because you do have other challenges that perhaps take a higher priority at the early design stage, such as your road layouts, how the master plan's arranged, safety, public realm usage, and also viewing lines and aesthetics may be come into play. So there's many factors here, so it can be a little bit tricky, but there are some simple principles that architects can use and be aware of. Next slide, please. And last but not least, lighting is a really easy win, really. Certainly cost effective. All developments should be moving towards LED lighting. It's a really easy win. It helps massively with operational carbon. I'm not too sure the embodied carbon savings are significant, but operational carbon savings certainly are. I've put the thermal comfort checkbox here as well, because some high wattage lighting solutions do kick out heat as well, and in the summer that's the last thing you want, particularly in evenings when you're turning your lights on and it's already still 25 plus degrees outside. So certainly moving towards LED is a really easy win, and everyone should be doing it. Next slide, please. So not only are those 10 design solutions good things to look out for, and I'd encourage you to maybe have a little checkbox for those 10, but there's also these processes to consider during housing design. In-use monitoring can definitely be a useful mechanism and process where developers perhaps report back to the councils, and local authorities can hold developers accountable by having an in-use feedback. Maybe tricky in terms of data, GGP, I can never remember the acronym, but data sensitivities, about giving up data. But there's certainly methods to help occupants reduce their consumption by having appropriate metering in place, so that occupants can see what's consuming the most electricity, and how they might be able to control their environments and their energy consuming devices a little better. I think there's also a big thing around occupant education and how and when to control various relatively new technologies like heat pumps and mechanical ventilation. So upskilling and educating occupants is important. And then training for planners and people like yourselves, I suppose, to help encourage good design within developments through the 10 points that I've shared earlier, and through CPD seminars and sessions like this. I think they're really valuable things to help share knowledge and help encourage good design. Next slide, please. And then finally, delivering and achieving net zero carbon homes, I fully appreciate it come without its challenges, but there are certainly some opportunities around it. So on the challenge front, certainly cost is often picked up as a key thing, but I think some of those design solutions I've presented earlier can address that. There has in the past been a problem around how we define net zero carbon, and hopefully the new building standard addresses that and gives us all something to point to and say, right, that is good practice and that is progressive and acceptable net zero carbon design. Knowledge and skills is without a doubt a real challenge in our industry. It's full of jargon. Even myself, and probably no doubt Mancy's learning every single day, and there's loads for lots of people to learn. So sharing knowledge and skills is a huge part of it. And things have changed a lot over the last few years in the sustainability world. It's been a bit of a whirlwind, certainly in the last 3 to 5 years. There is a bit of a challenge around precedent for net zero carbon homes. There's perhaps not many out there, and Mancy will show you some of the case studies later that will hopefully give some inspiration and references for you to point to. Tradition, I guess we are stuck in our ways a little bit. House builders have been designing houses the way they know how. Local small scale house builders are perhaps a bit nervous to move away from what they're used to. Air source heat pumps and new technologies like that are perhaps, they're a little bit nervous of moving down that direction. And perhaps a bit of a lack of motivation or driver from either their perspective or someone holding them to account has been a bit of a challenge in times gone by. But I think, like I say, there's definitely been a bit of a step change over the last 5 years, and there's been different drivers and motivation from different directions. The market in particular, home buyers are wanting more from their homes and they're looking for more sustainability credentials. We've obviously had a bit of a hike in terms of energy prices of late, so people are looking at their potential fuel bills and wanting a bit of a better solution. But net zero homes do give us a bit of an opportunity. I think it does give us the opportunity to deliver more high quality homes and hence address that quality point that I made at the beginning. It does give us the ability to address fuel poverty. Net zero homes will and should mean lower energy bills. The whole premise of net zero encourages us to design homes that have a lower demand for electricity and energy in the first instance, which naturally means lower fuel prices. They certainly do and should result in healthier homes if designed correctly. You get nicer environments, less condensation, good air quality in your homes if maintained well. It gives us the opportunity to try and network heat in local regions and share heat around a little bit more. In theory, that does have a better impact on the NHS. Lower health concerns, people living in more healthy environments should have a positive impact there. And then I suppose there's a bit more of a future gazing thing around how batteries are incorporated into our homes in the not too distant future and how that might help us with our nationwide carbon targets and reducing the daytime load that we put on the electricity grid, and batteries can be a really useful thing to help with that. And I think that's embodied carbon, operational carbon. So over to Mancy, who will give you a little insight into embodied carbon.
Thank you and good morning, everyone. I'm Mansi Desai and I'm a technical director and head of sustainability at Pearl Fishman. We are a sustainable design and engineering consultancy. I've been working within sustainability for over 20 years now, delivering low carbon climate resilient schemes for various sectors, including buildings, land development, transport, energy, and water. My team works alongside our multidisciplinary environmental and engineering teams to offer pragmatic designs and advice both to the public and private sectors. And we've been doing a lot of work with Homes England as well. So picking up from what Ben's shared earlier, When we think of net zero homes, we often focus on energy efficiency. We've spoken a bit about solar panels or insulations, smart appliances. But there's another important factor we can't overlook, which is embodied carbon. Now, embodied carbon is the amount of greenhouse gases which are associated with the construction and life cycle of a building or infrastructure. So while operational carbon, which is heating, electricity, etc., are often addressed in net zero designs, embodied carbon focuses on the hidden emissions within the building's life cycle. So in the next few slides, I'm going to take you through some of the key considerations to make, what it all actually means, and also share some project examples. Next slide, please. So embodied carbon accounts for a large proportion of emissions in energy efficient homes where operational energy can be minimal. So you may think that your design or development proposal includes solar panels or double glazing or low energy electric supply or all of the wonderful considerations that Ben was talking about earlier, but your overall carbon impact could still be high because of your embodied carbon. Now, in buildings or housing developments, certain materials are known to have a particularly high carbon footprint due to the energy intensive processes that are involved within their extraction, manufacturing, and transportation. This is not an exhaustive list, but amongst the most carbon intensive materials are concrete, steel, and glass. Concrete, especially when produced with traditional methods, releases a significant amount of carbon dioxide during the cement manufacturing process. Steel production also involves large-scale emissions from smelting and refining processes. Additionally, glass, and Ben's spoken a lot about glass, whilst often used for its aesthetic and energy-efficient properties, can have high embodied carbon if not made from recycled content. Then there are materials like aluminium, brick, insulation, which also contain energy intensive processes. So within insulation materials, for example, XPS, which is the extruded polystyrene, and closed cell spray foam have the highest amount of embodied carbon. So by understanding and addressing the carbon impact of these materials, builders and developers can take those important steps towards reducing a building's overall carbon footprint, both embodied and operational. Next slide, please. So what accounts for embodied carbon of these materials? Each of the materials that we looked at in the previous slide and any of the other materials that we've spoken about today, or you might know of, which are used within housing developments, all of them go through this process, which includes extraction of virgin materials such as aggregate, metal ores, etc., if they are not used from recycled process, that is. Secondly, manufacturing and the refining of those materials. The transportation of the materials to the construction site, so the greenhouse gas emissions from the vehicles for transportation. The construction and installation, which may require specialized equipment, electricity, water, labor, etc. And it doesn't stop there. It also includes the disposal of materials. Most of the sites would have some form of existing asset. And so the demolition or dismantling of the existing asset and disposal of those includes a lot of carbon. And once operational and in use, the maintenance, the repair and repurposing of an asset also has embodied carbon. So as you can see from the infographic below, every stage of the life cycle includes embodied carbon, right from extraction to landfill and recycling. Now, if you look at the use and maintenance of the building, that's where your majority of your operational carbon sits. And this relates to the figure that Ben had shown earlier. So embodied carbon truly is within every stage, and it's a very important point to address when you're wanting to develop a net zero home. Next slide, please. So developing a net zero carbon asset requires driving down the embodied carbon to an absolute minimum. So early involvement is key. The earlier the involvement in the design process, the bigger the potential carbon saving and embedding of sustainable design practices. So as the companies are committed to net zero pathways of their own, as governments are being committed to net zero pathways, they are now also focusing on reducing the carbon footprint of what they're building. So less embodied carbon can mean a lower requirement for carbon sequestration. This is a vital step in reaching global emission reduction targets. Whole life carbon approaches ensures that, all of the factors that contribute towards the creation, maintenance, and operation of a home, which ranges from material choices, construction methodologies, maintenance, operational energy, water usage. It also includes planning for cost and funding, that all of these considerations are taken into account. Next slide, please. So when it comes to building homes, infrastructure, commercial spaces, the decisions made during the initial design phase have a lasting impact on the structure's carbon footprint. We've seen this on every project that we are involved in. The earlier you get involved, the earlier you start deciding what sort of sustainable practices you want to adopt, the greater the impact from not just a carbon perspective, but also from a cost perspective. It's easy to think that reducing carbon emissions is something that can be addressed later, perhaps through energy efficient technologies or renewable energy sources. However, by incorporating carbon right from the start, we can make a far more lasting difference. So how do you do this? Number one is setting clear net zero goals right from the start. And whilst doing so, ensuring that the targets are aligned to building standards. We heard a bit about the building standards, and also local, regional, and national net zero targets and policies and standards. Every local authority has some level of net zero targets. Every organization also are having their net zero targets. So making sure that all of those are taken into account. It's not just at an operational level for an organization, but you drive down your targets to an actual project level. The initial design stages is where the foundational choices can be made, especially with regards to what materials are being used, how the building is designed, how is it going to be constructed, how will it interact with the environment. These are all questions that you should be asking right at the start. For example, choosing prefabricated and modular techniques can help lower the embodied carbon, and also addresses the changing landscape of the industry. We are seeing a shift from building assets, that are built for a 50-year lifespan. You need designs that are adaptable. And finally, implementing life cycle assessment also allows for the integration of renewable energy systems in ways that can make more sense for the building's specific needs and location. So this proactive approach will allow the designers to create energy systems that are highly efficient, cost effective, and further reducing our reliance on fossil fuels. Next slide, please. So just taking a kind of a sidestep, it's also important to consider low carbon design, but what does this mean from a planning context? I'm not going to go into too many details of what exactly the planning regulations say for each type of assessment, but it does involve integrating sustainability and carbon reduction strategies at the earliest stages of your design, planning, and construction process. Now, as per the planning guidelines, there are specific planning validation checklists, which include sustainability and energy statements, including carbon assessment, incorporating designs like SUDS, sustainable transport planning. If you are within any of the London local authorities and borough councils, then you've also got the circular economy statements that need to be prepared. All of that includes carbon assessments. There is a greater emphasis now on achieving low carbon, energy efficient, and sustainable design, often which promotes the integration within renewable or green technologies. More and more local authorities, and we're seeing this, are looking at schemes that can demonstrate a sustainable design measure, which considers environmental, economic, and social pillars of sustainability. For example, delivering biodiversity net gain, which is mandatory 10% on new developments, which is now a legislative requirement. It can also improve the amount and quality of biodiversity on site. But what does that mean from a carbon perspective? Planting trees, shrubs, etc. helps with carbon sequestration. So that helps bring down the overall carbon, along with supporting sustainable drainage features, and helping attenuation in flood risks, etc. LPAs are also looking to ensure that the sustainability and environmental planning policies are being adhered to when approving planning application. Now, although there are no penalties as such for non-conformance to any of the guidelines apart from BNG, at the moment, we are seeing more and more planning applications receiving conditions or being rejected due to lack of carbon considerations and sustainable design measures. Many of the local planning authorities are placing a growing focus on increasing climate resilience and reducing carbon. For example, declaring climate emergencies. So this focus is likely to increase, particularly in line with the proposed government housing and planning standards and the building regs that we heard about earlier. Next slide, please. So incorporating carbon within your planning consideration does not require a major shift really from your current practices. Whilst you engage with your local authorities on environmental impacts or design features, you can also work with planning bodies to align the net zero goals and highlighting the sustainable benefits. Presenting findings on how projects can minimize the embodied carbon impact through environmental impact assessment, which is EIAs, and it already looks at climate change resilience and vulnerability, materials and waste as key EIA considerations. And this is also an opportunity to invest and showcase low carbon material benefits. So by providing evidence to the authorities on how sustainable material choices can reduce carbon impact. I understand there is a cost implication to that, but if we are to reach our net zero targets as a sector and as a country, then we need to start making these kind of choices right from now. And of course, through community engagement, informing your stakeholders on the wider benefits, such as improving air quality or biodiversity, human health, and longer, lower term costs as well. Next slide, please. So I'm just going to take you through a couple of project examples where we've looked at embodied carbon, but also from a wider planning perspective. Next slide, please. So the first case study is your O2 Finchley Road scheme. We are commissioned by Landsec to prepare a residential-led hybrid planning application for the redevelopment of their O2 Finchley Road retail site. Now, the site is 5.6 hectares and bound to the north and south by Network Rail and Metropolitan and Jubilee lines, respectively. The emerging master plan seeks to create a locally integrated and a highly sustainable new community in the London borough of Camden. So the scheme's emphasis was on developing high-quality green infrastructure. The plan included providing approximately 1,900 homes set within a modern, low-carbon, energy-efficient apartment blocks. Now, Landsec also have a net zero carbon by 2030 target, which the O2 scheme had to contribute towards. So we worked with Landsec and ensured that their sustainability targets as well as planning policies and are taken care of and are included within the design. And we involved pioneering best practices within low carbon design, making this an exemplar scheme. So at Pell Fishman, we have an in-house optioneering tool, which is called EC4S, which is embodied carbon tool for structures. Early on into the investigation, design, and optimizing the solutions for this particular scheme. Looking at various framing typologies, grid optimization, and low carbon materials, for example. Each solution has been assessed for embodied carbon, ease of disassembly, and off-site manufacturing, all of which reduces overall carbon as well. So for embodied carbon, our original target was to reduce to 500 kgs CO2 per meter square, in line with LETI standards, but we are already reducing it to 300 kilograms carbon dioxide per meter square. The image on your screen is a bit blur, apologies for that, but it does show the carbon at various life cycle stages, right from production to end of life and recycling stages for each material as well. Our focus was also on targets for biodiversity, water and surface water runoffs, material use, circular economy, especially since it's in the London Borough of Camden, and waste. Next slide, please. The next example is of a residential-led mixed-use development scheme in North Ashchurch. So in 2019, the Tewkesbury Garden Town achieved Garden Town status, and the focus was to create new communities in a complete and well-rounded manner. So this involved excellent housing options, providing job opportunities, and establishing important connections to essential community amenities. So North Ashchurch is set to play a crucial role in establishing the benchmark for the Tewkesbury Garden Town communities. These will form around, if my memory serves me right, around 4,000 new homes where people can live, work, raise families. So there is schools, there is workspaces that are being developed, local parks, etc. The community will also be well connected through pedestrian and cycle-friendly routes as part of a sustainable transport network. So the proposed focus was on three main themes: creating green spaces and nature, movement and placemaking. So the new housing delivery as part of this scheme will likely be subjected to the government's new future home standards. Currently, the project inputs from our side involves inputs into the environmental statement and the planning application. So as part of this, we are providing support on energy and climate resilience work, which covers assessment of whole life carbon, so both embodied and operational, as well as topics of material and waste, looking at key considerations to kind of understand the impact on climate change. Now, as you can see in the graph, we have identified the key carbon hotspots, looking into low carbon material options such as ashcrete, for example, a concrete alternative that uses fly ash. We're also setting a higher reuse and diversion from landfill targets to achieve circularity. And we are also collaborating on producing the scheme's energy strategy, which promotes low carbon, renewable, and energy efficient technologies. One of the examples is air source heat pumps, for example. Other relevant topics include biodiversity net gain and the potential benefits from carbon sequestration, management of materials and waste. Is waste actually waste, or is it a resource that can be reused? So we are maximizing the reuse potential at this site. We are also doing geo-environmental assessments to make sure that any material that is being excavated is actually good to be reused on site. And we're also doing land assessments and transport planning. So this is really a well-rounded scheme where we're not just looking at material carbon, but carbon within every element of the design. Next slide, please. And finally, this is a commercial scheme, Space House, which was originally designed by architects Richard Seifert and Partners and structural engineers C.J. Pells and Partners, now Pell-Fishman, between 1964 and 1968. So the building received a Grade 2 status in 2015. The scheme includes two blocks: Tower Block, which is 15 stories, and Kingway Block, which is 7 stories, with link bridges between the two blocks and a 2-story basement. So Pell-Fishman, along with GT, BAM, Atelier 10, and Squire and Partners, were key in delivering the rebar design stages 4 and 5 of the scheme. The scope included revitalizing Space House, bringing it up to the standards of a modern workspace. It also included transformation of the public realm and turning the basement from an underused car parking into an event space and a cycle parking. The structure required to achieve net zero, and so we use the reuse and redevelopment principles to achieve the targets. This was another scheme where we used our in-house EC4S carbon tool, adopting the use less approach to minimize any additional carbon. So what did we do? Spare structural capacity was identified and utilized. helping develop a low carbon and a lightweight structure. Now, through our interventions, we managed to save approximately 10,000 tons of embodied carbon through maximizing the retention of existing structure. So that is by reducing demolition and providing a low carbon, lightweight new structure. We also ensured that the new design enhanced natural daylight, thereby helping improve energy efficiency as well. The new structure is more than 3 times lower than LETI 2030 target. So for those who don't know, LETI is the Low Energy Transformation Initiative, which was originally the London Energy Transformation Initiative. LETI is a network of professionals who are working to put the UK on the path to net zero carbon future. This scheme also received a A++ structural carbon rating scheme, which is scores, that indicates a building's design has near zero carbon emissions. And the scheme also achieved a BREEAM outstanding rating and was the first grade 2 listed building refurbishment to achieve this. Now, Space House was also shortlisted this year for the iStruct T award, and the building has recently been opened to the public. Next slide, please. So when considering carbon or sustainable housing development, it's not just about materials and energy, but as I've tried to show from some of the case studies, there are wider considerations that should be taken to achieve net zero development as well. This includes biodiversity, which not just helps with, enhancing the natural and the built environment, providing health and wellness, but also acts as carbon sinks, whilst having a positive overall impact as well. Sustainable drainage helps with tackling climate change, and developing a future-ready development. A great way to reduce carbon is the inclusion of active travel considerations. A modal shift to active travel and public transport helps to reduce the need of other road network improvements to increase the road capacity. And adopting principles of circular economy to reduce our reliance on new materials, thereby diverting materials from going into landfills, which are already at maximum capacity. And so we're reducing embodied carbon through that as well. So this is not an exhaustive list, but this is definitely some of the considerations that, you need to be taking, or you can achieve rather, if you look at overall net zero carbon. Next slide, please. So there are several design principles and considerations that feed into a net zero home, as well as increasing sustainability across the whole development. Some key examples include following the carbon reduction and the waste reduction hierarchy, and designing for longevity, adaptability, and disassembly, and promoting the reuse and recycling of materials as well. So making low carbon material choices, for example, instead of using conventional concrete, investing in earth-friendly concrete. Appreciate that this could come at a price, but there are wider long-term benefits. So there could be some upfront cost of using a new material or a new technology, but it will have wider carbon and overall environmental benefits as well. Now, EFCs have the potential to reduce carbon footprint by 70%. They are durable and can be used in ready mix and precast concretes. Another example is ashcrete, a concrete alternative that uses fly ash. And I think this can reduce about 25% of cement in concrete, thereby reducing the overall carbon emissions as well. There are also some places where hempcrete bricks, which are made from hemp, lime, and water, are used. Other examples include using timber as a material option, or straw bales as insulation. Using new innovative materials might, like I said, it does come at a slightly higher upfront cost, not always, but they do provide cost benefits in the long run. Another very important one is choosing local and green suppliers, choosing water and energy saving technologies, and using renewable energy to move away from our dependence on fossil fuels. And finally, adhering to the targets and standards. within national and local policies, but also going above and beyond the legal requirements to make a bigger impact. Reducing embodied carbon should be a priority for developers and contractors for many reasons. These could be legal limits on embodied carbon, and these will become a mandate, because we've got very strong net zero targets coming up, and it may be a key requirement to obtain planning permission in the future as well. So these are really important points to remember. And next slide, please. So to end, I just want to leave you with this slide. Currently, there are various barriers around, high upfront cost. I've spoken about some of that, and limited availability of low carbon material. But with increased demand, the supply will increase, and thereby the costs will come down, and the acceptance of these materials will increase as well. Someone's got to start first, right? There is need for investment into future solutions and support from the governments on standardizing policies, which hopefully will be driven by the new building standards. Retrofitting a house instead of building a new one can save about 68% of embodied carbon. According to the World Economic Forum, addressing embodied carbon in housing is a scalable solution and could cut about 4.6 billion tons of carbon emissions, while improving the state of housing globally. So there's a huge financial drive as well as reducing your overall carbon. Homes England, we know, is already leading the industry with what they call demonstrator projects, which are like pilot schemes, where they look at cost-effective, scalable net zero solutions. For local councils and developers, and I know there's quite a few of those on the call today, this is also an opportunity to lead by examples. Most of you all are carbon committed or will have your own internal targets. So your efforts can be a catalyst for an industry-wide change. And for the likes of Homes England, the next steps for implementation could come from stronger commitments to applying these practices into all of your projects. For example, making a targeted requirement for tender documents to drive change, as an example. So in conclusion, addressing carbon considerations, both embodied and operational, early on is a vital step to achieve sustainable goals. It is proactive approach that can ensure that the building is not just functional and aesthetically pleasing, but is also environmentally responsible. I think that brings me to the end of my slides. I think that was the last one. Yep.
Thank you very much, Mansi and Ben. Incredibly interesting. I can see in the chat that there's lots of discussion going on. It's a really difficult area because, thank you everyone for the hand claps. It's such a difficult area because there's a lot of influence needed from government, local planning authorities, developers. Everyone needs to be working on this together and using what power we have, what ability we have to drive down carbon. And it is a very difficult topic. So I appreciate all the comments in the chat, and some of you have answered other people's questions for us, which is great. So we're going to move on to a short Q&A session. We've selected some of the most popular questions, and then we'll put these to Ben and Mansi. So if you can make sure your questions are, you're ready for the questions with your camera on, I'll make a start. So first question, and we're sort of trying to take them obviously chronologically, some of these questions. So Ben, there was a question about whether your advice and your top 10 tips, did that relate to new build only or also retrofit, i.e. existing buildings?
I should have clarified that a bit more at the beginning, but it's largely new build, but out of those 10 design features, probably 4 of them you could apply to retrofit.
Yeah, thank you very much. That was a nice quick answer.
I suppose also it's really in context of, if there are a lot of local authorities on the call, it's looking at those planning applications that come in and trying to assess those new designs from a energy, operational carbon, embodied carbon, thermal comfort, daylight perspective, and trying to get those design features incorporated in those planning applications. So largely new build. Appreciate there's a huge retrofit market out there, but yeah.
There is. And Homes England gets involved in retrofitting, and lots of those considerations that you've mentioned would be relevant to those as well. So the next question is, does the UK building standard, the net zero carbon building standard, let's give it its full name, does it include commercial and non-residential development? I think that's a fairly easy question to answer.
It does. I've just seen someone said which four though. Let me just go back to the previous question. So out of those top 10, you could definitely apply number 6, fossil fuel free. Number 8, in theory, you could go back and retrofit district heat networks. Number 10, you could do lighting changes quite easily. And what was my fourth one? Oh, external shutters for windows, easy to retrofit. So there are 4 in there that you could apply. And yes, net zero carbon standard includes all sorts. It's quite heavily data backed, actually. It's not just people plucking numbers and targets out the air. They've looked at all sectors. Some sectors have got a bit more detail than others. Homes in particular is split up into single family homes, flats, but then you've also got a commercial residential, and that's for student residential and care homes. So there's specific targets and limits for operational and embodied carbon for all of those home typologies. It does apply to retrofit as well as new build, so that's an important point. You can use the standard for retrofit. I think that answers that question.
Yeah, great. So a question really for both of you, and maybe Nancy, you'd like to start on this one. To be carbon beneficial, somebody has asked, we need to ensure electricity produced is from non-fossil fuel sources, and how do we know, and how can we guarantee this? Nancy, have you got a view on this you'd like to start off, and Ben, you feel free to add.
Sure. So one of the things is, and this is what we're doing within our company as well, is moving to REGO contracts. So REGO contracts is a government kind of approved contract which ensures that your energy is coming from renewable sources. And there are various ways to kind of check where those energy sources are coming from. So that's, I would say, REGO contracts is one of the options.
Ben, do you want to add anything to that?
Yeah, we are reliant somewhat upon government and UK national legislation in terms of decarbonisation of the electricity grid. You'll see year on year that the carbon factor of electricity is reducing, and there is forecasts for it to carry on that way. We're a little bit at the mercy of that electrical decarbonisation plan to help us decarbonise our homes. So it's a little bit out of our control. So my suggestion, proposal is to focus on what we can control around design and planning applications, and good practice.
Okay, thank you very much. Any advice regarding airtightness? There's a net zero policy in Cornwall, and I see lots of comments about Cornwall and what they're doing in the chat, but some developers struggle with good airtightness. We understand it's more of a quality issue than a cost issue, and we're supporting training, but we're told that it is an issue for developers, is the comment in the chat.
Yeah, I think it's really sensible to focus on training. I think there is a big piece there to be done. I think that's where the lion's share of the work can be. I think sharing precedent with the building community is a good way of doing that. Encouraging people to show examples of how they've achieved airtightness, and again, the devil's in the detail, right? There's going to be loads of little examples that people have addressed. Really simple stuff is just looking at mechanical and services penetrations into the fabric. So whenever you have those, soil stacks, water pipes, electrical cables coming in, making sure that there's adequate sealant around those. That's where a lot of the damage is done, where you break air tightness lines. And there's also particular challenges around junctions, walls to floors, floors to ceilings. I found actually doing my own house and looking at this in context, and those pictures were of my own house actually, was that having an air permeable membrane on the inside is a really easy mechanism to try and get your air tightness up, rather than trying to apply it to the outside of the insulation. If you think about in practice, if you're going out for a walk and you put a big thermally insulative jacket on, you then probably would put a more of a windproof layer over the top of that. You wouldn't necessarily put that windproof layer underneath that. So it's not the best way to do it, but it is an easy mechanism. And then things like wet plaster can have a big impact if you're putting a membrane behind wet plaster, and then the wet plaster is adjoining the walls to the ceilings. That's a good mechanism to get an internal air tightness membrane, or an air tightness skin, if you like. Sorry, a little bit of a long-winded answer there.
No, but it's a problem, and it's a technical issue, and I think the training of people increasingly so, and also the people to inspect what has been done to ensure it is airtight is always an issue, isn't it? That they've got the sufficient capability to inspect it. So a question.
I think that's just
Sorry,
on that, Janet. Actually, I think that's a good point, and accountability can actually be a really valuable process or mechanism to help give people a little nudge along. You know, if you're holding people to account by having air tightness testing mandated or in planning permission conditions, then, you know, even if it's a sample, then you're holding people to account. They have to show you their answer. I think that can be really, really powerful.
Yeah. I always say, no point in asking something and then not checking that it's actually there. So a question for both of you, but we'll start with Mansi. So you've talked, both of you, about the changes that need to happen to reduce the carbon in houses. I like to say lower carbon rather than net zero, so that it's not sort of misunderstood. But, you know, you talked about those changes that need to happen to both operational and embodied carbon. And the question was, what would be the impact of these changes on house prices and the costs of, obviously, of building, and that some people wouldn't be able to afford a lot of these improvements, no matter how good they are at helping net zero, and that is a question that I think we're all considering and thinking about and discussing even within Homes England. But I also think there's a lot of misconception about the costs of reducing carbon. So Mansi, would you like to say something about that, perhaps, and start off?
Sure. There's a few things here, isn't it? The first point is developing a low carbon home is not necessarily expensive. You know, that's one of the first ones. There are options, there are alternatives where if you use for example, solar panels, and you've got surplus energy that can go back to the grid, and, you know, so there is a financial gain there that the homeowner can have. There needs to be support from the governments as well, and I don't want to get into the politics side of things, but there should be support from the government side of things as well, to kind of ensure that any new developments that are happening are net zero, which means there's the funding that's available to invest in new types of materials, new technologies, so that takes away the pressure from the developers. So I think, yeah, for me, those would be some of the main ones.
Yeah, Ben, would you like to add anything to that about the impact of reducing carbon on cost?
I think we've just lost Ben.
We just lost Ben. Okay, no problem. We'll move to a different question, and hopefully Ben can rejoin. This is inevitable in a video call, isn't it? Okay, so there was one question. I don't know whether you can answer this, but Ben might be able to when he comes back as well, about contingency plans for breakdowns and maintenance when you're putting in all these different technologies. I don't know if you can talk about that.
I think when you are, and that's why, you know, early considerations and looking at these technologies early on in the design is really important, and also looking at the whole life cycle of these technologies is also very important. when you look at new materials that are being developed and brought into the market, they all come with an environmental product declaration, which kind of says how the material is developed, what is the science behind it. And that then helps plan your future maintenance intervals as well. So ensuring that all of those considerations are taken into account will definitely help with that maintenance periods. Um, yeah, I think that's what it is.
Yeah, I mean,
Yeah.
and obviously with technologies, we need to ensure that the technologies we put in have some longevity to them and can actually be successfully maintained into the future. And
Absolutely.
we're not
It's
putting in
also
something. Yeah, go
Yeah,
on,
and it's also
Nancy.
about being flexible, something that I was talking about. We need to move away from having those designs which are box standard or can last you for 100 years, because we don't know the changing landscape.
Mm,
Things may
mm,
look very different in the next 20 years or even 10 years. And so your designs need to be accommodating. They need to be you need to be able to take a design from one place and fit it into another place as well. So, like modular
mm,
developments are a great example. I know it's not always possible, but
mm,
these are some of the things that need to be considered. I was having a really interesting conversation the other day with someone where we were talking about when you buy a new house, firstly, people want to do up their houses so that it's ready to sell. But then I go in, I buy a new house, and I don't like the kitchen because it's not to my liking. And so I want to remove everything and I want to fit in a new kitchen. That kitchen is absolutely fine. It doesn't
mm,
need a
mm,
replacement. But people would want to replace it just because they don't like the color or they don't like the
mm,
brand of the
mm.
equipment that is being brought in. And I think it's really important to kind of, there's also a level of being conscious and taking accountability ourselves as well, to make sure that, we're not just jumping into using the most recent materials or the most kind of popular materials. But if things are working, let it work, use it till the end of its life, and then
Mm.
look at replacing it. So I think there is a huge personal kind of behavioral change aspect to this as well.
Yeah, absolutely. Okay, so I'll move on to a question about climate change. There's been a
Mhm.
couple of questions around the bigger picture there. Climate change is obviously impacting on us all across the globe and in the UK, and we need to therefore reduce carbon emissions. There are lots of other things we need to do as well, but that's one of the things. Therefore, building regulations need to be tightened up and sorted rather than individual planning authorities doing something in their local plans, was
Yeah,
one of the questions. And then there was a question about climate resilience and building that into what you're doing about carbon, building
yeah,
in climate resilience with regard to landscape drainage, all sorts of other things that we need to build in to make sure buildings are resilient.
yeah.
So, I suppose the question is around how do we ensure that building regulations are tightened up to make buildings and places more climate resilient?
Absolutely. So, yes to both of those points. Climate change, climate is very real. For whoever says climate change is not real, you are kidding yourself, because we've seen the extreme weather patterns that we're seeing, the extreme flooding events that we've been seeing within our country and especially within Europe as well, and the huge impact it has on existing assets. Um, and then because of that, the carbon that sits within it. So it's very much real. It's really important for climate change adaptability to be embedded within the design early on. The new building regulations does look at the entire built environment. It's a combination of your REBA, LETI, all of these standards put together into one regulation, and which
Mm,
talks about climate change, which talks about embodied and operational carbon, and so which is coming into effect, as Ben said, early next year. And so it's really important that during the initial stages of design development and
mm,
planning, climate vulnerability, climate impact is taken into consideration. And this is where linking it to other things like biodiversity is really important, because
mm,
that has a direct benefit if you are achieving your biodiversity net gain, if you are ensuring that you've got a green space there where you can enhance the biodiversity, that helps with flood attenuation, for example. It reduces surface water flooding, and so which has a direct impact on climate change as well, or rather avoids it. So yes, absolutely agree.
Yeah, I think your slides and Ben's slides very much were focused on the interplay of all of these things as a system, to make sure that they're all working together, not just focusing in on, we see quite often people saying carbon tunnel vision. They've got to actually build in all of these things.
Absolutely. And it's you have to look at it from as an ecosystem. We need to move away from the siloed approach of working. That you do a carbon assessment somewhere, you do an operational assessment somewhere, you look at biodiversity somewhere. No. And that's why some of the examples that I was trying to share today about the master planning, we are not just looking at, I know this is a net zero home presentation, but in those master planning example, carbon is a very important role, but it is actually a very small role, of considering carbon and the assessments that we're doing. It is that overall link that where sustainability and carbon's like that thread that connects all of the different aspects within planning. Transport planning is something that we've been working with Homes England on as well. It is really important because you're looking at how through sustainable transport planning, you can reduce the GHG emissions, which directly has an impact on climate change. So all of these things are linked, and it's about also educating ourselves, to exactly what do all of these definitions mean and how are they all interconnected, I think is really important.
Yeah. Absolutely. And as you say, making sure that you're considering these things at the early enough stage that you can influence and change the direction of them, which is very much what Homes England is attempting to do, and does in many cases already, is take that holistic view of the whole development and do it early enough and look at the master plan and placemaking. I know it's a term we've had around for a long time, but placemaking is very important. So a very specific question for you, Mansi, and I'm really hoping Ben's going to get back in again. I think it's because he's joining after we've got so many people in already. He's struggling a bit, so we'll just keep going and hope that he catches up. So what is the benchmark for confirming the 10,000 tonnes of embodied carbon saving? The new build alternative? So somebody's asked that question because you had that figure in one of your case study slides.
Sure. So I'll take a step back to the carbon tool that we developed. So the carbon tool, our EC4S tool that I was talking about, is aligned to PAS 2080 and is aligned to your LETI standards and your I/T standards. So that's where the carbon factors come in. And so those are what are used to ensure that, so that's the benchmarking really. So that's what's used to ensure that if we say it's 10,000 tons of carbon, then that is kind of verified because it aligns itself to the past 2080s, etc.
Okay, thank you very much. So somebody asked a question about timber. I don't know whether you were able to answer that. So it would have been good to have Ben there. I think he is back in and sort of listening. But so Georgian Victorian homes have been around for a long time. What longevity will modern timber frame or SIPS homes have in our wet climate? And are the centuries-old breathable buildings and their embodied carbon a thing of the past? That might be sort of related as well. But let's take the timber question first, because I know from my experience of my own home that the timber that was used in buildings for centuries, and my father would comment on this, the timber that's used in modern buildings is not necessarily the same.
Oh, that's a very interesting question, isn't it? More for Ben, probably. But when you look at any of the other materials, timber is one of the most sustainable materials that you can use. I think it depends on where your timber is coming from. So let's not forget, for any material that we talk about, it's not just the material itself, but it's the processing of the material, which is where most of the carbon sits. So it depends on where the timber is coming from, the transportation of that timber to site. And so Victorian homes, they probably could have had, local timbers, for example, and Ben might come in and say, "Oh, Mansi, whatever you're saying is absolutely crap." But my understanding of materials is that, and carbon within materials is that it really depends on the processing of those. New timber. I know there is a regulation where all of the timber that is now used needs to be IFS certified, which means that it is a sustainable timber. It's coming from sustainable resources, which hopefully then helps bring down the carbon, because how do you measure carbon is all of these materials have a carbon factor. And so when you apply the carbon factor to the amount of material that is being used, that's how you understand what the carbon is within that material. So it really depends on what the carbon factor of the new timber that is coming in, their carbon factor is. But I know that all of the new timber that is being brought in needs to be sustainable timber.
Yes, and indeed, if you're building with timber, there is a certain amount of biogenic carbon that's stored in that timber, so it can be a good material to use from that point of view.
Absolutely.
We're getting a lot of pressure and questions about the Future Homes Standard. Whilst we don't want to comment on that, because that is for ministers to decide and the new government to review and decide what they're going to do about that. I wondered if you had a view on the Future Homes Standard, and whether it goes far enough, and you can have a view on that, certainly, even if I can't express my view.
It definitely is better. It's definitely a shift in the right direction. Governments are becoming more and more conscious about our net zero targets. UK's overall net zero target is 2050, but that is as a nation. Now, every sector has their own internal targets as well, and there are roadmaps, which is 2030, 2040, 2045, 2050, of how we should be reaching there. Personally, and this might not go down very well, but I've been working in the industry for almost 20 years. And I feel like we are 10 years too late in doing something effective and tangible. And that's why there's even more need of doing the right thing now if we are to achieve the 2050 targets. We are already too late, but we need to start. And yes, someone has agreed with me, so thank you. It is true, right? So the new standards, even the new building regs that are coming out, they are a step in the right direction. They are moving away from the siloed approach of just looking at operational carbon or embodied carbon. It is taking the entire ecosystem into consideration. It's taking all of the three pillars of sustainability into consideration, which is your environmental, so water, floods, your noise, air quality, pollution, land quality. It is also taking the social impact into consideration. So what does all of this mean from a human health perspective, a human wellness perspective? So it's really important that all of those considerations are also taken into account. And from an economic standpoint as well, I'm not saying that the standard actually tells you what sort of economic benefits you're going to have. Absolutely not. But if you do the right things, it will mean that there will be an economic benefit to it as well. If the entire industry moves towards using low carbon materials and sustainable materials, there won't be a massive price impact on that. So that's what it is. You can't work in silos, and I think that is what the standards are trying to do. They are trying to move us away from that siloed approach of working.
Yeah, thank you very much. And I can assure all of the participants in this low carbon that we are as passionate as you are about pushing things as much as we can. So I certainly am, and so are my colleagues. So you can be assured that we are working hard on all of these things. Don't worry about that. So I think we're going to have to draw things to a close now. We're coming to the sort of time. So before we leave, we'd like to hear from you, and I'm obviously thanking Ben, who wasn't able to get back in properly into the call, but thanking Ben and Mansi and everyone for attending and your passionate and interesting comments and questions. It's wonderful to know that you all care so much. Just do what you can, use your power. We've all got to do our own individual things, and obviously through our organisations. So we finished a couple of minutes ahead of schedule. So we'll just round off there, and that concludes today's sessions. And we're very, very pleased to have your input, as I said, throughout the session, and masses of questions and comments. So thank you very much. Goodbye from me, and goodbye from Ben and Nancy and all the LGCC team.
Thank you so much, everyone.
Thank you.